This is the last part of Chapter 6 that we're going to go through before you have your test. It is finding equivalent expressions or combining like terms. So the I can statement is at the top. It says I can combine like terms to be able to simplify an expression. And we're going to go through what a term is and review that. Okay, so make sure you write that I can statement down. And then when we add or subtract, when we have addition or subtraction signs and they separate parts of an algebraic expression, that's when each part is called a term. The numerical factor of a term that contains a variable is called the coefficient. And a term without a variable is called a constant. Okay, those are review words that we should have already covered with the first lesson. Right? And then like terms contain the same variable. So like x, 2x, and 3x, they all have x in it, so they're all called like terms. So the goal here is to really combine terms that have a similar variable in it. So if we look at this first example, we're going to count how many terms they have. Okay, so this one has 1, 2, and 3 terms. Again, terms are separated by an addition or subtraction symbol. Okay, so we're going to write 3 terms up here. And then these arrows at the bottom indicate that the 3x and the x are like terms because they contain the same variable x. Okay, so again, for 4n plus 2n plus 9, we have 1 term, 2 terms, and 3 terms. So that's 3 terms. The 4n and the 2n are like terms. And then that 9, again, when you have a number not attached to a letter or a variable, that is a constant. All right, turn the page. All right, to simplify an algebraic expression, use properties, and we learned about the properties already, to write an equivalent or an equal expression that has no like terms and no parentheses. Okay, so our goal is to write the most simple expression that we can. So if we have 4 times x, or 4 times 6x, 4 times 6x, remember, I can distribute that 4 to be stuff inside parentheses, and I get 24x. Alright, simplify the expression. This is like saying 3x times 11. Well, I can work backwards and distribute that 11 to the 3x, and I get 33x. Right, and then we have x plus x plus x, so I'm going to simplify that expression. Again, this is repeated addition, which is multiplication, so I have 3 x's, so 3x. And in example 4, simplify the expression, I have 7x plus 8 plus x. Okay, so here is really where we start to think about simplifying or combining like terms. The 7x and the x are alike. So if I have 7 x's and I'm going to add another x, I'm going to have 8x. And then that 8 I can't combine because it doesn't have an x in it. So 8x plus 8. Alright, now we're going to work with expressions that have 2 variables in it. So if I have 4y plus x plus 22y, okay, I know you're supposed to do parentheses first, which you always should, and I am going to, but I can't combine the 4y and the x because the y and the x are different variables, so I cannot combine those. But what I can combine is the 4y plus the 22y, because they both contain that y. So 22 plus 4, we get 26y, and then I still have that x, so 26y plus x. Okay, we're going to use the distributive property in example 2. So 4 times 2x and 4 times y. So 4 times 2x is 8x, and 4 times y is 4y. Again, those are different variables, so I cannot combine them. Example 3, 3x plus 9y plus 2x. Okay, the 3x and the 2x contain x's, so I can combine those, and 3 plus 2 is 5x, and then I have that 9y. Okay, use a distributive property to distribute the 7 to everything inside. So 7 times 3x will give me 21x, plus 7 times 2y is 14y. I cannot add 21 and 14 because they have different variables. Okay. You are going to try to do the back, and then we will go through those.